Question number 46 now. Question number 46 says calculate the time taken for a mango fruit that falls from the tree 20 meters to the ground, given that g is 10 meters per second square. So this is a free fall. So a mango falling from a tree is a free fall due to gravity. So and we have the tree height of the tree, to be 20 meters, and g to be 10 meters per second square. Now you know that your s is equal to the distance ut plus a half gt square, but in this case, because the distance is now a height, okay, so your s would be equated to h, and this would be equals to ut plus a half gt square. Now because initially the mango was actually at rest while on the tree before it started coming down, so your u would be 0. So if u equals to 0, your h will be equals to 0 times t will be 0. So you have this to be half gt square. Okay, now what you're actually looking for is time taken, so you can just quickly just do that. Your 2h equals to if you cross multiply, 2h equals to gt square, so t square is equals to 2h over g. So your t would be equal to square root of 2h over g. That's to get the t. Now the time is equals to, we're given to be h to be equals to the height of the tree to be equal to 20 meters, divided by acceleration due to gravity is given to be 10. So we have this to be equals to 2 times 20, that will be 40, over 10, that will be square root of 4, and then time will be equals to square root of 4 will be equals to 2. Okay, so you have that to be 2 seconds. It takes 2 seconds to do that. Now question number 47. Number 47 says which of the following is not a mechanical wave? Which of the following is not a mechanical wave? So we have waves in closed pipes, radio wave, water waves, and sound waves. So all these are mechanical waves which require material medium for their propagation, except radio wave. So radio wave is not a mechanical wave, and it's not a mechanical wave. So radio wave is not here. Radio wave is not a mechanical wave. Okay, so question number 48 now. Number 48 now. We have the velocity ratio of an inclined plane where angle of inclination is theta is what? The velocity ratio of an inclined plane where the angle of inclination is theta is what? First thing to know here is this is under machine. The velocity ratio is distance moved by the effort divided by the distance moved by the load. So here you have velocity ratio to be equals to distance moved by the effort divided by distance moved by the what? By the load. So here, let's say you are carrying a load to a point, let's say point A to B. This is actually the height. Then you're moving the load from, let's say the distance the load travels is an inclined plane, Yeah, so let me clean up a bit. So let's say we have something like that. Yeah, something like that. Aha. So we have this to be A, B, and then let's say this point is C. Okay, now so this is the distance moved by the load, but the effort, this is the distance moved by the what? By the effort. You're carrying a load from here and you're taking it up here. You're carrying it from here, you're taking it up here. The actual distance moved is this distance, but you use this your energy through this distance. So now if this is the angle theta, your sine theta is opposite all over hypotenuse. Your sine theta is opposite all over hypotenuse, all right, which is equals to the opposite is AB all over CB. That's your sine theta, opposite all over hypotenuse. This is the opposite, this is the hypotenuse. All right, now your velocity ratio here is distance moved by the effort is CB, okay, divided by the distance moved by the load, which is AB. So if you compare this and this, you see that they have an inverse relationship. Okay, so your velocity ratio is therefore equals to 1 over what? Sine theta. The velocity ratio is 1 divided by sine theta. That's question number 48 now. Question number 49, you have the volume of a fixed mass of gas is 10 centimeter cube when its pressure is 40 centimeter mercury. Determine the volume of the gas when its pressure is 200 centimeter of mercury. So we're giving the volume of this thing to be equal to that. So here you remember that your pressure is inversely proportional to your volume, okay, from your Boyle's law. So you have your P to be equals to K over what? Over V. When a proportionality sign changes to an equality sign, a constant is introduced. So you have K to be equals to PV. Now from here you have your P1 V1 equals to P2 V2. Okay, now we're giving the first volume V1 to be equals to 10 centimeter cube, and we're giving P1 to be equals to 400 centimeter of mercury. Then we're asked to calculate V2. We don't know when P2 would be 200 centimeter of mercury. Now, so if we apply this formula now, P1 V1, that's 10 times 400 equals to P2 200 times V2. We don't know. So V2 equals to 10 times 400 divided by 200. So this here 1, this here 2. So we have that to be 200 as well. So this is 2, that's 20 rather. So this is going to be 20 centimeter cube. So V2 will be equal to 20 centimeter cube. Now question number 50. Question number 50 says, which of the following representation is correct for an atom X with 28 electrons and 30 neutrons? Which of the following representation is correct for an atom X with 28 electrons and 30 neutrons? So here we have X you have electron to be 28 and neutron to be 30. Okay, so an element X would normally be represented as X. You have atomic number, had a subscript, and then you have mass number here. Mass number, that's what you usually have an element like represented. Okay, so in this case now, the mass number here is 28 plus 30, which will be 58. Then your atomic number would be 28. So therefore you have this represented as 28, 58, 28, 58. So that's your answer, probably A. All right, so that's question number 50. Thank you for the time. All right.